Most of you would have probably heard about the infamous Pythagorean theorem. The square of the hypotenuse of any right triangle is equal to the sum of the squares of the other two sides. Thanks to him, we need to learn about it in second grade, second semester. But can you prove that this works? A lot of you, I'm sure, will prove the theorem with Euclid's method. Here, triangle AFB, half of square ABFG, has the same area with triangle CBF, because they share this base and have the same height. Triangle ABD and triangle CBF are congruent shapes, having the same area, and triangle ABF has the same area with triangle BLD. The same goes with triangle ACK and LAC. Triangle BLD and LAC add up to become half of square BDEC, which are halves of square ABFG and ACKH. Therefore, we can infer that square AB plus square AC is equal to square BC. But did you know that there were 370 other ways to prove this theorem? The one you know is just the most famous example. Here are some of the other examples of proving the theorem. This is the method Pythagoras himself used. Here you can see that four right triangles, AHE, DHG, CFG, and FEB, form a square. Since all the angles are identical, another square is formed in the center. This square has the area of square ABCD minus four right triangles. Each right triangle has an area of AB over 2, so the area of the center square is a plus b squared minus 2ab, which is a squared plus b squared. But we can also know that this is also same as c squared. The theorem is proved once again. This method was designed by Bhaskara, an Indian mathematician. This method is somewhat similar to Pythagoras' method. See, square ABDE is identical to square GFCH's area plus 4 of the right triangles. The square on the center is a minus b squared, which is a squared minus 2ab plus b squared. Each right triangle, just like Pythagoras' method, is ab over 2. So if you add up 2ab and a minus b prime square, you get a squared plus b squared. I mentioned earlier that the square is identical to c squared. Now we can note that the theorem is proved one more time. We looked at 3 methods of how to prove the Pythagorean theorem. 1 by Euclid, 2nd by Pythagoras, and 3rd by Bhaskara. When we live, we get to see a lot of rectangles, and because of that, we get to see a lot of right triangles. The Pythagorean theorem lets us know how long the hypotenuse of any right triangle is, which would be very helpful to our lives.